Hello, everyone, and welcome back to the Cloud Security Alliance Global AI Symposium. This session is titled See Yourself in Cybersecurity Careers in the Age of Artificial Intelligence. And I am Ed Adams, Head of Cybersecurity North America for Bureau Veritas. I will be taking you through this presentation over the next 30, 40 minutes or so. And I'm looking forward to presenting this information to you because it's a very exciting topic and it's very near and dear to my heart. I want to start by giving you a brief introduction about myself in case you don't know who I am. As mentioned, my name is Ed Adams, and I am the head of cybersecurity for North America for Bureau Veritas, which is a nearly 200-year-old company that focuses on certification, inspection, and testing of all things, everything from food products all the way to IT systems, which is why security innovation is now part of Bureau Veritas. I am also an author. You see the book in the bottom right, See Yourself in Cyber, which was published by Wiley a little bit earlier this year in 2024. It was an Amazon.com bestseller. It won Cybersecurity Book of the Year. I'm very happy that folks are finding it useful and popular. I also spend a fair amount of my time working with a nonprofit called Cyversity, which is dedicated toward improving the lives of women and other underrepresented minorities in cybersecurity. In my earlier days, I was a software engineer and mechanical engineer, and I did fun things like building non-lethal weapon systems to capture folks without injuring them. So I've got a lot of technical experience in my background, and that led me into the world of cybersecurity 20 years ago. And speaking of cybersecurity, that's what this conference and this topic is all about. And these are the three main agenda items we're going to be discovering. I'm going to start by talking about artificial intelligence's superpower and a dirty little secret that a lot of folks might not understand about artificial intelligence, but it gives us a superpower to help deal with it. We're then going to talk about the evolution of software as we've come from desktop software all the way through to cloud and artificial intelligence. And then I'm going to spend some time talking about the cybersecurity color wheel, which is a topic introduced in my book, See Yourself in Cyber. And I'm going to focus on what I call building yellow jackets and exercising the yellow color of your cyber muscle. So let's start by talking about artificial intelligence. And all the rage these days, of course, is the generative AI tech stack with things like ChatGPT and Anthropic's cloud and such. And if you look at this diagram, it really identifies all the different layers of the artificial intelligence technology stack, starting with the chips themselves, the graphical processors, the cloud computing hardware that is doing a lot of the crunching. And then after that, we go through the data management layer, the machine learning frameworks, the pre-trained models like the LLMs, the large language models like Anthropic's Claude, APIs, other tools, and then applications and interfaces. And the dirty little secret that I want you to understand is that after the hardware stack, which is just the chips, it's all software. And when I say it's all software, I literally mean it's all software. The data on which we train our models is software, it's databases. The large language models, those LLMs like the GPTs and the Claudes, that's software. How we connect into them with our APIs and using open source software like OpenAPI and Hugging Face, that's all software. And then the applications that we build to consume those for our own business purposes or personal purposes is also software. And software is flawed. As a matter of fact, take a close look at that image on the right-hand side. It was generated by a generative AI tech stack. And you'll notice it's got errors. It's got spelling errors. It's got image munging errors. That's the issue with software. And that's one of the core issues about artificial intelligence. It is software. It is flawed, just like the humans that built it. And we need to understand that and attack it. So let me take you on a very brief history level about the evolution of software security and how we've grown with the times. So I want to start talking about this. And I'm going to go back to late 1990s, believe it or not. And that was the time when we were webifying the world. And this is what I refer to as the era of software rising. This is right around the turn of the century where we were taking all of these applications and putting them on the web. And that gave birth to beautiful organizations like OWASP, the Open Web Application Security Project. And that spawned the creation of things like OWASP Top 10, which I'm guessing everybody that's listening to me knows what OWASP Top 10 is. It's the top 10 threats to first a web application, but then they developed top 10s for mobile, and then for IoT, and then for APIs, and now for artificial intelligence. But as we continue to evolve, software, we also continue to involve software to application security, and software started to get more connected even in devices. So we got the launch of things like IoT and machine-to-machine communications and machine learning as software became embedded in all of the phones that we're now using with smartphones and medical devices and automobiles. And then we continue to evolve because as we realized that software is in all of these IoT type of devices, we said, oh, we better secure this at the source. So we started talking about this concept of shifting left in the product development lifecycle, more toward code, more toward architecture, more toward requirements. But then here comes the cloud and DevOps. And what the cloud and DevOps gave us is not just scale, but the evolution and emergence of new tools like CNAP and software composition analysis, and that started to displace and complement some of the older technologies like static analysis, security testing. And we started to think about, well, shifting right is also important because now we're taking this software, we're putting them on these devices, but now we're connecting them to cloud infrastructure. And we also have to shift to the right to look at deployments and configurations. So this is how we've evolved over the past 25 years with desktop applications coming all the way through to cloud, and now we're layering artificial intelligence on top of that. So let's talk a little bit about what has changed and what hasn't changed. Well, what has changed for sure is the technology stacks, and we see that. We see this going from web applications all the way through cloud and artificial intelligence today. That's what I just walked you through. Also, software applications today really aren't built from scratch. They're not coded like they used to be. They're assembled like a car. So you take a Ford, F-150 pickup. Ford doesn't make the tires. Ford doesn't make the seats. Ford doesn't make a lot of the body parts. They source them from third parties and then assemble them, and it becomes a Ford F-150 pickup. That's how software applications are built today. They're not coded from scratch anymore. They're assembled from third party, and all of a sudden that brings in the critical importance of supply chain security with our software, with our cloud, with our artificial intelligence. So that's what's different from 25 years ago. But let me tell you what hasn't changed. What hasn't changed are the types of threats and attacks that we're seeing. Sure, they're on different technology stacks, but it's the same type of attacks. Attacking design, attacking misconfiguration, attacking user input, attacking bad identity and access management, attacking unpatched and using old components. These were attacks we were talking about 25 years ago. These are attacks that James Whitaker wrote in a book called How to Break Software Security, published in 2002. These are also attacks that are perfectly relevant today. We're just taking the same attacks and applying them to new technologies. That's what the hackers are doing. That's what we need to wake up to. And also, development teams haven't necessarily improved their knowledge about security according to this dark reading survey that was published in May. What they did is they asked a bunch of different security teams what they thought or how they would rank their development and operations teams, their DevOps teams on security, from not knowledgeable at all to not very knowledgeable to somewhat knowledgeable, blah, 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 blah. In 2023, 17% were rated as either not very knowledgeable or not knowledgeable at all, the two worst elements. In an updated survey in 2024, that increased to 30%. So as of this year, information security teams are looking at product development teams and saying about 30% of them, from our perspective, are not very knowledgeable or not knowledgeable at all about security. And this is an increasingly growing problem as we're increasingly dependent on software and product teams to run our digital enterprises. So that's the challenging news. Now comes artificial intelligence. And if you ask artificial intelligence about information security, application security, software security, cloud security, cybersecurity, what is it? How is it interrelated? You'll see it gives you this kind of tree diagram about information security. And underneath that, there are subsets like software security and cloud security. But underneath software security, there's application security and product security. But you can't have product security without cybersecurity. As you can see, there's a lot of interdependencies. There's a lot of overlap between info, app, software, cloud, and AI security. The key message I want everyone to understand here is that software runs our digital and connected world, full stop. It runs the cloud, it runs IoT, it runs automobiles, devices, artificial intelligence, it even runs hardware. We're seeing increasing firmware attacks. And when it comes to emerging technology trends, software is literally the glue that keeps us stuck together, so to speak. So you look at devices, you look at cloud, you look at APIs and microservices, so much of it is software dependent. So as security professionals, as security executives, we need to understand not software. We don't have to be coders. We don't have to be technical. We need to appreciate the security implications of what software means to our world, because we are trying to secure all of these things. We're trying to secure web applications, cloud native applications, lift and shift applications, APIs, infrastructures, blockchain, now artificial intelligence, all the mobile devices that are brought into or we offer to our staff. We have to secure all of that. And software runs through every single piece. That is a key understanding. And a couple of minutes ago, I talked about how artificial intelligence is essentially all software once you get past the chipset. Very, very current attack that was reported on large language models like Anthropic's cloud, where attackers were able to expose keys and then run chatbot services at the victim's expense. So they're attacking these LLMs, inserting themselves into the artificial intelligence tech stack themselves and taking over because we're not practicing those fundamental security measures that all software needs, that all IT stack needs. And this is exactly the fear that we all had, is that once we start using artificial intelligence, what's going to happen to us in terms of if it gets hacked, then what? And because we depend on artificial intelligence for guidance, for intelligence, this is now potentially poisoned. And you can poison the data on which the LLMs are trained. You can hijack the LLMs themselves, and that's the case of this particular attack reported by SC Media. And you can also attack the user inputs or the user interfaces. Again, the exact same set of attacks that have been plaguing us for over 20 years. Now, fundamentally, vulnerabilities are mistakes that your teams are making. And it's not always their fault. Humans are fallible, software is fallible, IT is fallible. But we do have to understand that is a fundamental truth, that vulnerabilities are mistakes that our teams are making, because we can never be secure throughout all of our digital enterprise. You just can't. And I mentioned a few minutes ago the reliance on supply chain when it comes to software. As you can see from this research report from the 2024 Open Source Security Report, OSSRA 2024, 77% of all code in all the code bases that were analyzed originated from open source. That's more than 3/4 of your software that your staff didn't write. So that's just a reality of today. And by the way, 84% of those code bases contained at least one vulnerability. So you are inheriting vulnerabilities as you assemble your products, as you assemble the software that goes into your products, whether it's cloud products, web products, or physical products. And the complexity of these modern products is now staggering. I mentioned a Ford F-150 a few minutes ago. That was not by accident. You take a Ford F-150 from 7 years ago. This is a 2017 Ford F-150, and it has 150 million lines of software code. 150 million as of 7 years ago. And it had over 100 chips, 5 different networks, 10 different operating systems. And that's the pickup truck you're riding around in downtown, wherever. I repeat, focus on fundamental security principles has never been more important. We have to stress this throughout our entire staff. The DevOps team, the security team, I think the security team understands it, but we are outnumbered. If you look at your own organization, you look at the teams that build, the teams that operate, those DevOps teams, how many of those staff are there compared to your staff in an information security or global information security practice? They are typically 5, 10, 50, or 100 times the number of IT and DevOps staff than there are information security staff. So we've got a big job to do to help educate those folks. So why are we so vulnerable? Why are these tech teams so vulnerable? Now, I talked a little bit about how we're not focusing on the fundamentals. We are still making the same types of mistakes that we made 20 years ago. And part of it is people like me. I was a CEO for 20 years. I'm an executive. And we all want the latest and greatest stuff. So we, as a society, love to chase the shiny new toy. What happens is that we adopt these technologies faster than we learn how to secure them. This happened with the web at the turn of the century. It happened with mobile, 2008 through present. It happened with IoT. It happened with the cloud. It is happening with artificial intelligence today. We adopt new technologies faster than we learn how to secure them. That's just the fact. We're like this little toddler running down the street after the ball. But who's waiting in the shadows to pounce on us? Well, it's not Pennywise from Stephen King's It, like is pictured here, but it's the attackers, it's the hackers. It's the malicious actors, whether they're nation state or hacktivist group or disgruntled employees or unintentional mistakes. But those are the things that are waiting to get us. So it's the same mistakes we're making on different tech stacks. So we're still chasing that shiny ball rolling down the street. And remember, I'm not asking security teams to become experts on software, just like we would never think to ask software teams to become experts on security. That's not how it's going to work well. I am going to show you how it does work well in a few minutes, but that's not what we're asking you as security professionals to do. What we need to do as security professionals is understand software enough to understand the threats that it is posing to our organization, understand how software and IT systems are built and by whom, and that's not as easy as it might sound, and then convey common mistakes and work with those organizations to help educate on small but important areas. And what we're doing is we're trying to raise the tide and lift all the boats when it comes to cybersecurity acumen. I mentioned how we're outnumbered by a factor of 10 to 100 to 1 when it comes to DevOps teams versus InfoSec teams. Well, that outnumbering also provides an opportunity to scale. So if you can train 100 people on just one topic and improve that cybersecurity acumen, you can raise the tide, and then you train them on a second topic and maybe a third. It's a lot better than trying to throw a whole bunch of stuff at them and say, please just learn all this stuff. Trust me, I've done it. I've done it where it failed, and I've learned how to do it where it succeeds. That's what we need to learn how to do. And I'm going to show you a successful model in a few minutes. But first, I want to go back to OWASP Top 10 because there's a new OWASP Top 10, and it's called OWASP Top 10 LLM for large language models. It's all about artificial intelligence. Now, this OWASP Top 10 has threats that are specific for AI, but look closely. Improper error handling, data leakage. You've got prompt injections. Injection has been the top of the OWASP Top 10 list on web, on APIs, for so many years. It's the same fundamental things we're not doing, sanitizing user input, for example, that's causing things like prompt injections to show up number one on the OWASP Top 10 for LLMs. Another model I'll offer, again, harking back to OWASP, is their software assurance maturity model. It's called SAM. And what SAM offers is 5 different business functions, from governance all the way through to development and operations, and then the security practices aligned with each one of those functions. And it's great. I love SAM. I think it's terrific. But if you look at the security practices, things like application risk profiling, software security requirements, secret management, defect tracking, and for defect tracking, we're talking about security defects, configuration hardening, etc. You think, oh yeah, of course, these are all, security things, makes sense. Well, sure, it makes sense to us as security professionals, but we're not the ones doing all those things. These are the things that are asked of the development teams. That checkered dark yellow box that goes around design, implementation, verification, and operations, these are the builders and operators. These are the DevOps teams. We need them to do configuration hardening. We need them to do security defect tracking. We need them to do software security requirements. That's what that's how we're going to be successful. And I'm going to give you a few examples of just some skills, some job-specific skills that are not in information security. These are on those DevOps teams, product owners, cloud architects, site reliability engineers. So for example, product owners need to understand how to safeguard applications, infrastructure, and the operating environment. So they're the ones that are making the requirements definitions. They're the ones building use cases. Well, great. Extend those use cases to include security, or build completely new abuse cases if you want to. It doesn't matter which way you go, but product owners need to think about security as an aspect of product quality, which they're already responsible for. Are your DevOps teams responsible for functionality? Sure. What about performance? Yes. Reliability? Sure. Accessibility? Oh, what about security? Talk to them about security as an aspect of product quality, and now you're talking their language. You're going to get much more responsiveness. These are just some examples of skills that we need to build. I want to dive a little bit deeper, and I want to start talking about the cybersecurity color wheel. The cybersecurity color wheel was introduced in my book, as I mentioned, in 2024, called See Yourself in Cybersecurity Careers Beyond Hacking. And the reason I use a color wheel is because we in cybersecurity use red teaming and blue teaming all the time. We're familiar with it. It's the model extended from military operations where the red team attacks and the blue team defends. We get that. We know it. We live in this world. But I wanted to also include those folks that we have to interact with that don't live in our world, the non-security jobs. And I'm going to be talking about those in a minute. So the color wheel, cybersecurity color wheel, does talk about attack specialists and security specialists, those red teams and blue teamers that we know. And here are some of those typical job functions around pen testing, red teaming, forensics, SOC centers, etc. And you combine red and blue and you get purple teaming. And this is a typical war gaming where you have a red team attacks and a blue team defends to see, well, how well are we doing? Do our defenses hold, or et cetera, et cetera. That's all wonderful stuff. Keep on practicing it. Learn more about purple teaming. It's a wonderful thing. But I really want us to focus on not just the breakers and defenders that we know well, but the bakers in the middle. These are the chief information security officers, the legal teams, the risk and compliance folks. They provide the guardrails. They give us the guidelines. That's why I colored them white. They're kind of like a leading, shining light that shows us the way to go. But I really want us to focus on the yellow teams, the builders. These are the folks that are constructing the IT systems that we use to run our enterprise and to sell to our customers. These are the development teams, the engineering teams, the IT teams. These are the teams that are outnumbering us in cybersecurity 10 to 1 to 100 to 1, typically. And this is where I want us to try to focus when it comes to education. So we take yellow teams, we teach them a little bit of red teaming to turn them orange. We teach them a little bit of defensive blue techniques to turn them green. This is how we start learning things like attack to defend and defend by design, etc. This is really where I'm going to focus the next 5 or 10 minutes on the presentation, and I ask that all of us focus our efforts when it comes to education around our teams. Now, just a quick nod to April Wright, who first introduced the concept of an InfoSec color wheel. And this happened at a Black Hat presentation that I saw her deliver maybe 6 or 7 years ago. What I did is I took April's model and I extended it, and I took a deep dive really into the DevOps teams. So we talked a lot about artificial intelligence, how it's structured, the dependence on software, and what we can do as executives to help build awareness. Now I want to give you some very, very specific, practical, implementable steps. That's all well and good, Ed, but how do we do it? Well, the first step in how you do it is starting with context. We want to talk to development and operations teams about our world. But in order to be effective, we need to tell them about our world, but use their words. I talked about the concept of security as an aspect of software quality, and I think that's pretty important here. But not as important as normalizing language and understanding that in a DevOps team, it's not just developers. And I can't tell you how many executives I've spoken to, even your chief information security officers, who come to me and said, "Oh, Ed, I need to train my developers on security." And the first question I always ask them is, well, what do you mean when you say developers? And unfortunately, a lot of times they really don't know. They just group everyone into the category of developers. And one thing that's important for us, especially if we're going to be responsible for either procuring or overseeing the education of these teams, is to understand that in a development team or a DevOps team, there are many, many different job functions. And I'm a big fan of the NICE framework from NIST. That's the National Institute of Cybersecurity Education, NICE. And they built this NICE framework that talks about 52 different job functions or work roles in cybersecurity, and then all of the knowledge and skills and tasks associated with all of those 52 work functions, those work roles. It's wonderful, but it's incredibly limited because it doesn't really address the DevOps world. It doesn't address those 10 to 100 times the size of the staff that we need to help educate. It has, I believe, one work role that talks about development, and that's it. In a DevOps team, you have, as we saw a few slides ago, product owners, you have business analysts, data analysts, you have cloud architects, system architects. Even just in the world of developers, you've got front end and back end and database developers and web developers and full stack developers. You have cloud engineers, you have automation engineers, you have site reliability engineers, you have database administrators, you have DevOps engineers, you have all of these functions don't code. All of these functions are not just developers. So you have to appreciate what their job functions are, because if you follow what I'm about to tell you in a few slides, where you start with just one attack and show them how it impacts them, it will be incredibly valuable if you can show them how it impacts them in their specific world. Well, what do you as an architect have to think about when it comes to injection? What do you as a cloud engineer have to think about when it comes to injection? And they are very different things, trust me. So that's the first step, is talk to them about our world, our security world, but use their world, use their words. And remember, because I get this a lot, I'll talk with the CTO and I'll say, okay, I'm here to help train your IT and your DevOps teams on security. And I always get well, wait a minute. I don't want to train my DevOps team. I don't want to turn them into hackers. Like, great, I don't either. We need them to develop. We need them to be DevOps teams. I want to take your yellow team and give them a little bit of zing. I want to give them a little stinger. I want them to stay yellow teams. We need them to be yellow teams because yellow teams build all of the products and the infrastructure that we depend on. I want to make them yellow jackets. Just like a wasp, kind of like a wasp, I want to give them a stinger. And I love using red teaming to do it because hacking is cool. Everyone understands hacking and breaking stuff, and it's really fun to hack stuff, especially when it's not your own. The objective here is not to turn development teams into hackers. It's to develop an attack mentality. Because the fact is, if dev teams cannot find the common vulnerabilities and common mistakes that I walked through and that we've been making for 25 years, ever since OWASP came into existence, if they can't find those common vulnerabilities, they're likely creating those vulnerabilities, and they're not implementing the defenses needed to mitigate those. Even worse, they're going to struggle on how to fix them. Even if you have a security team that's finding the vulnerabilities and reporting them to the dev teams, they won't know how to fix them. And I love this quote from Molly Struve, who, by the way, is not in security. She's a site reliability engineer for Netflix. One of those roles in the DevOps world that's not security and that does not necessarily code all the time. She happens to. Well, she says, and I quote, "Now when I code, my first thought is, how could I hack this? What if I changed the form input here? Would we reject it appropriately?" So Molly's thinking about error handling. She's thinking about failing safely. She's thinking about all the things that we want her to think about when it comes to things like injection, which I'm going to talk a little bit more about. The reason that Molly is able to have this change of thought and she has developed an attack mentality is because she went through a training exercise similar to what I'm going to recommend to you here, where it started with some red teaming activities. We chose just a few things to train this group on. Let's show you about injection. Let's show you about cross-site scripting. And let's show you what the implications are. And that really helps trigger a light bulb. So now you have site reliability engineers and cloud architects whose job is not security. You've got them thinking about security. And that's what we want. That's what I was talking about raising the tide and lifting all the boats. We've got 100 people in DevOps to one person in InfoSec. Well, let's train those 100 people on one or two really important things and improve their cybersecurity acumen, because that's going to be a lot easier and a lot more scalable and a lot more impactful than trying to hire 2 or 3 or 4 more people in cybersecurity, because we know they're tough to find, they're tough to scale, and they don't necessarily know software. They don't necessarily know the IT world. So we want to take advantage of that body of knowledge and inject it with a little bit of cybersecurity. So how do we do it? So there's 3 steps that I recommend for this. And it's be giving, be nasty, and be open. And I'm not going to go into these in great detail just because we don't have enough time to go into them in detail, but I'm more than happy to do that if you reach out to me, and I'll give you all the details behind how to do this for your specific environment. But the recommendation here is, as you're going to mix your palette, you're taking your color wheel, you want to take those yellow teams and make them a little bit orange. I like to start small but focused, and I like starting with those red teaming activities. I like to choose one of the OWASP top 10, start with injection. I love injection. I think it's a very easy to demonstrate the implications, as well as easy to show how things like injection can be addressed at multiple phases of a product lifecycle, which is important because you want architects to be thinking about injection. You want developers to be thinking about injection. You want the test and quality assurance folks to be thinking about injection. You also want the deployment and configuration teams to be thinking about injection. because you can help mitigate at each one of those steps. Now we've got defense in depth. Holy moly, another principle that we are now able to apply. So be giving, be nasty, be open. Let me talk about what that means. Be giving. First of all, we've chosen one threat. We're using injection in this example. Give them something that's easy to consume, and think about giving them that piece of information in multiple different media types, because people learn in different ways. Maybe give them a 2-minute video on injection. Maybe give them a cheat sheet on injection. Maybe give them a presentation on injection. Maybe do a lunch and learn 30 minutes, and then you feed them to educate them what is injection, etc. That's the giving part. And when you approach someone like a CTO, you might say, oh, Miss CTO, I'd like to train your DevOps teams on security. And if you get that pushback, you get that response, well, no, we can't. We have deadlines. We have features to get out. Well, Miss CTO, I only want to train your team on one thing, just one. And let's see how it goes. I promise I won't take up much time. I promise it will be impactful. And you can say that because I know this works. So you give them something like that. But that's only the first step. That's where a lot of training programs end, and that's a huge mistake. You have to then walk them through it, because once you've been giving, now you have to be nasty. You have to demonstrate to those DevOps teams how their stuff can be broken with the very thing you just gave them. And for this, I love cyber ranges. I love using red team or offensive cyber ranges so I can demonstrate injection. I can show them, okay, we talked about injection. Now let me show it to you. And let me show you what happens when a cloud application or an API or a user input prompt for something like ChatGPT is susceptible to injection. Let me show you what happens. You're getting nasty. And once you've been giving and once you've been nasty, be open. And here, I mean, just talk with your teams. Open a discussion. I like lunch and learns here. I like whiteboard sessions. Bring your DevOps teams together and say, hey, we talked about injection. I showed you how it really messes up your stuff. Now let's talk about what we might be able to do about it. And what you're doing here, by the way, is you're running a threat modeling exercise, and you're not even talking to them about threat modeling, because that will freak them out potentially. But that's really what you're doing. And use mediums that might work for you. I see some organizations run a whole hacking day where they bring DevOps teams together and say, you know what, for the next couple of hours, we're going to show you a few things, and then I'm going to turn you loose on this cyber range and hack away. And we're going to be here to answer questions. That's a great idea. Be giving, be nasty, and be open. And what is the result? Well, the result to me is a peacock, because security is like a peacock to me. And when people first hear this, they think, all right, Ed's lost his mind. What's he talking about? Security is nothing like a peacock. But this is what I mean when I say security is like a peacock. We trained that team on just one thing, injection. That's the body. That's the bird, the body of the peacock. And we trained them on injection. And we trained these teams on injection with sensitivities to knowing that there are different roles in the DevOps world. There are product managers, there's architects, there's developers, there's testers, there are configuration and site reliability engineers. So what we do is once we train them on injection, and we've been giving, and we've been nasty, and we've been open, what happens is that now they start to think about, whoa, well, maybe we should include injection or security as part of our defect classification. Let's just include injection for now. They start thinking about, well, we can include injection as part of our coding standards to make sure that we are sanitizing all input that comes from an external source. They start to test for injection as part of the quality assurance before it's even released. Also, these cloud engineers, the configuration engineers, they're thinking, well, why don't we configure our cloud infrastructure to maybe filter for injection attacks? Because then even if the dev team builds a flawed application, we can still catch it in configuration. This is what you want. You now have architects, product managers, developers, testers, and cloud engineers talking about security, and you've only trained them on one thing. But what you've also done is now sensitize them to security. You've shown them how security is an aspect of product quality and software quality, and it can be integrated into their jobs. And oh, by the way, you're shifting left and shifting right all at the same time. This is how we succeed. I'm going to close with 2 slides. One, you can read the quotes yourself. These are 4 organizations that implemented exactly what I just walked you through, and they did it at scale. So they started small, then they added on, they added on, they added on. And these are organizations that I'm sure you're quite familiar with, organizations like Accenture, like Microsoft, like Citrix. And some organizations took different approaches. Citrix, for example, decided after they started their pilot program, they started small and they saw traction in their product teams. They decided they wanted to create a belt system, sort of like martial arts, white belts, yellow belts, black belts. And they tied it into their HR systems, their professional development, their salary and benefits. So if you achieved black belt, you got bonuses, you got salary increases, etc. And it was incredibly phenomenal, as you can see from the quote by Alex Rubin. And she did a wonderful job as the chief of staff of cybersecurity for Citrix. You'll also see organizations like Accenture in there. With Accenture, they were able to train over 110,000 software developers in 1 year through an entire security track. That's a phenomenal scale, but they did it. And they did it using this exact same process that I just walked you through. This is what we need to do for artificial intelligence. This is what we need to do for cloud, because so much of it is software dependent. So I'll finish with this slide: a fact, a flaw, and a secret. The fact is that our artificial intelligence transformation is enabled by software. We've seen this throughout the last 40 minutes. AI is essentially all software. The cloud runs on software. In order for us to secure AI in the cloud, we must focus on software. But the flaw is that we consume new technologies faster than we learn how to secure it. So just like that little kid chasing the ball down the street is about to get sucked into the sewer by Pennywise, we need to learn the lessons that we didn't learn well with web, with mobile, with IoT, with blockchain, with cloud. We want to learn it before it's too late with AI. But the secret is that DevOps teams care about quality, and you can turn those yellow teams into yellow jackets with a focus on fundamental security principles and that 3-step education practice that I just walked you through. This is how we raise the tide. This is how we lift the boats. This is how we increase the cybersecurity hygiene of your organization without making a single new hire. That's what I'm here to talk to you about today. And I thank you for spending the last 45 minutes with me. My contact info is up on the screen, as well as a link to a training benchmark report from the Paramount Institute if you want to download it. Once again, I thank you for your time. We're right at 44 minutes. I hope you've enjoyed this presentation. Thank you very much.